Hello all, welcome to our channel Way to Know. In this video, we will talk about one of the interesting topic on how to calculate the power consumption of Arduino Nano 33 BLE board. Okay, so what do we mean by power consumption and why should we do it? Right, power consumption basically, if you look at the BLE communication is one of the low power communication, low power wireless communication, right? The main advantage of BLE is even if you use some BLE chip on your board, using a RTC coin cell itself, you can get years of supply, and the battery can sustain for years, and that's the beauty of this BLE, right? The Bluetooth, correct? Especially the Bluetooth low energy. Bluetooth is meant for audio applications. BLE is meant for low power wireless applications. Anyway, audio, Bluetooth, LE audio is coming up, but that's a separate topic. So now in this video, what we are doing is we have a Arduino Nano board, okay? And in this Arduino Nano board, we are actually not just giving power directly from the USB. We are trying to give an external power. We don't have a DC supply, so if you are a hobbyist at home, you generally don't have a DC power supply, right? For that purpose, we have used a UART to TTL converter, which actually gives a 5 volt on one of the pins. So on the breadboard, we plugged in the USB to TTL converter, and you can see this red wire we are plugging out and connecting it to 5 volts of that, and we are giving it to one of the pin, which is nothing but VUSB. Like if you can see the schematic here, okay, so VUSB is the pin which we will be connecting this particular power supply. Okay, so now coming back to this board, so we are giving an external power instead of USB power, and then we also have the DHT11 sensor which we have connected, and what we are doing is on the schematic, if you see on the Arduino Nano 33 BLE board, and also we can see the same in the schematic, here you have SJ1 and SJ5 shorting jumper options. Okay, so this shorting jumper options are on the 5 volts of this particular VUSB, and we can actually connect a multimeter there to see how the current consumption is varying. For that, what we did is we soldered 2 wires on the pads, which is SJ5, which is on the top side of the board, and then we connected a multimeter. Okay, so now the Arduino Nano BLE is in advertising mode. Okay, so the current consumed during this particular mode is 4 milliamps, and what we did is in our blog, embeddedDesignblog.blogspot.com, we did a detailed power calculation of how much is distributed, how much current is distributed among the different peripherals of the Arduino Nano, and this how this 4 milliamps is divided between the peripherals. We did a detailed calculation. Okay, and I'll post the link in the description. You can have a look at it, and we will not discuss that here. You can look at it from our blog, and this we can also put it in a transmission mode, measure the current. So all the various scenarios where we can get to know the power consumption of the Arduino Nano 33 BLE board using this setup. Okay, and especially for beginners and college graduates who work on these boards on a regular basis, it is suggestible that you do perform this analysis and study the current under various scenarios to get to know how much the current is varying, and look at the data sheets and compare with the data sheets to see the variation between the data sheet and the actual consumption, and again go back to your calculations, see what you are missing if it is mismatching with the data sheet, and perform analysis and do a one-on-one comparison with the data sheet, such that you get a view of how much is the actual consumption the board is doing and how much the data sheet mentions. A very good exercise to get to know about the board, the insights about the power calculation, power consumption of the board, and you can do manual power calculations from the schematic, compare with the practical values, and you can see the deviations. A very good exercise, and this is one way how you can do power calculations on your Arduino Nano board. We haven't used any tools or anything, simple multimeter, Arduino Nano board, external power, and observing what's happening on the current side.